Okay, so in this video tutorial, I would like to go over different ways to construct the P chart. So I will start with R and then Python and also Minitab. So I already have R Studio opened up here. And the first thing I'm going to do, I'm just going to create a notebook real quick. So to build a P chart in RStudio, I will be using a package called QCC. So to install a package, you just go on Tools and then Install Packages, and then you can just type the name. It's called QCC, and then you can install it. So this is actually the first thing I'm going to be doing. I'm going to be calling the library QCC. And then I need to input some data. So I will call it def. And this will be in a data frame format.
What is a data frame?
So data frame is a type of data structure. It's basically a two-dimensional array-like structure, which in simpler words means a table. So it's a table format. I will just make sure that I call it data frame. I specify that. And then I need to start inputting my columns. So my first columns will be called the facts. And it will be a vector of some random numbers. And then my other column will be the group size, which will be also a vector of some values. I'm just going to make them all equal group sizes at this point. And I can print to make sure that this looks like what I want. Okay, so I have the first column, the facts, and then I have the second column, group size. So this means that out of 10 observations I took, 4 of them were defective. So to build a P chart, it's actually very easy using R. All I need to do is call P chart, and then with the data frame that I'm going to be using, I'm going to be building this control chart. I call my data again, so df, and then the first column, which is the facts. Then the second column, which is group size. And then I need to specify exactly what type of chart I'm building. In this case, it is a P chart. And then we can just Control Enter and build it. Okay, so right now I have P chart for df the facts. I don't like that, so I'm just gonna name it data name equal the facts. Okay, that's better. So this is what my P chart looks like at this point. I have the number of groups, the center line, standard deviation, lower and upper control levels, and then they count how many things were violating, were beyond limits or violating runs. So,
But how many sigmas are being used to calculate the control levels? I need 2 for my analysis.
yes, so we need 2 standard deviations to run the analysis, and the default is usually 3. So what we need to do is just specify that in our code, and it's called n sigmas equals, and then let's rerun this. And now we actually have a group that is beyond our control limit, so group number 5. We can use 1, for example, 2 also works, and now we are being even more strict with our control limits, and we now have 3 observations that are 3 groups that are out of control. So I couldn't really find a very easy package to just build the P chart or construct it in a much easier way. So we will have to build it from scratch using Python, but I will be providing the code. So you just need to change your data, update the data for your data. So the first thing we have is we're going to be importing the required libraries. So these are some of the libraries. I'm not sure I'm going to be needing the statistics one, but just in case, I'm going to be including that. And the first thing I'm going to be doing again is making sure that I input my data. And I already have something pre-made here. I'm just going to go copy and paste. So I have a first column, which are the trials, and then these are just names that I decided. So you can have, for example, Monday morning, like Monday morning, and then Tuesday night. So it really depends on what strategy you have. So you can change that. The defects and then the group size. So this is exactly like the RStudio example. I can print that just to see what it looks like. And this is what I have. So right now I have a collection of some data, some different data, and it's not exactly what I need. Again, I also need a data frame. So I'm going to be converting P into a data frame. So again, I need it to look like a table. So if I print P now, it is a table, and that's exactly what I need. Now the next thing I need to do, I would need to manually calculate the proportion for each group. So to do that, I am going to be adding a column called P, and the column will be dividing the number of defects by the number of observations, or the group size. So I'm going to print that again just to show you, and then I have the P. And the other thing I need to do is find a P bar, which is the sum of all defects divided by all observations. So it's whatever this adds up to divided by 80. So I'm going to calculate the P bar manually. And now I have everything I need to build the P chart. So to plot the P chart, I am going to add line by line so you can visualize how it adds up to the final plot. So the first thing I have is the proportions. So I have that group, first group is 0.4, then second group is 0.5, and it goes on. Then these two lines of code will include the control levels, control limits, the upper and lower. So this is basically manually calculated. These are the Y values, and I am using the regular formula to do it manually. So I have P bar plus 2. This is the number of sigmas I want. Then square root of P bar times 1 minus P bar divided by the group size. So if I run this again, I already have control limits. Next thing, I'm going to be plotting the central line in blue. And I want to also change the values here in the x axis, so it's easier for us to identify, because I don't remember exactly what was this observation. So it's simpler if I just replace these with whatever I have in my trials. Okay, good. And lastly, I'm just gonna add some other pampering to the plot so it looks a little bit better, some subtitles, and this is what it looks like. So we can already see that this observation is off, it's out of control of our control limits. So this is definitely something that we'll need to explore a little bit further.
What if I have unequal sample sizes?
So if you have unequal sample sizes, that's fine. We can also do that here. We can change, let's say that here we have like 20 instead of 10. Then we can rerun everything, and then we can. And lastly, using Minitab, here I have some different data. I have 15 days being observed with some different subgroup sizes. I have the number of defective units or failed, and I will use Minitab. So to build a P chart, you go to Stat and then Control Charts. It's an attribute charge and then P. Then I need to define what variables I'm going to be using, and the variables in this case is the number of failed units, and then the subgroup size is going to be the inspected number. And this is what it looks like. We have unequal sample sizes, so this means that the control limits are also uneven. Here we can see that nothing is out of control, everything looks good. But the truth is that we need 2 sigmas for our type of analysis. We want it to be, to be a little bit more strict. So to change the number of control limits, you need to go on P chart and then options. And then instead of having 3K over here, you need to switch for 2. So this P chart options is in this. Okay, so the P chart options is right here. And now we actually have one observation that it's out of control. And another thing that you can do is manually change the number of inspected units. So under P chart options, you can also change the limit. So we can assume all subgroups have equal size. And now we have a straight line for the control limits.